Okay, class. Today, we're learning about temperature conversions. Temperature conversions, we have certain rules. You can convert Celsius to Fahrenheit and vice versa. You can convert Celsius to Kelvin and vice versa. But you cannot convert Fahrenheit to Kelvin or vice versa because there is no direct conversion. So, with that being known, let me give you a couple of examples here. If we have 20 degrees Fahrenheit, we can only convert it to Kelvin and Celsius, right? So we'll put a K for Kelvin and a C for Celsius. Go ahead and put in parentheses so we know that's what we're looking for. Okay, class. Now, the first conversion we're going to get it to is Celsius. So if we have 20 degrees Fahrenheit and we want to convert to Celsius, first, this is the formula that we do. It'd be C for Celsius equals 0.56, and then you put in parentheses, and then you put Fahrenheit F minus 32. That's the first.
What?
Let's go ahead and shut up. And then it'd be, again, C equals 0.56. And then you put 20 because the F stands for Fahrenheit, and up here we have 20 degrees Fahrenheit. Okay, class? So it'd be 20 minus 32. Go ahead and do it on your calculators. Go ahead and give me the answer. And it'd be C equals 0.56. And you want to multiply, or you want to get the answer. Did anyone get the answer for 20 minus 32?
No.
Okay, to help you, it's negative 12. So we put negative 12 in the parentheses, because that's what 20 minus 32 would be, is negative 12. And then what we do is we multiply 0.56 times negative 12, which would give us negative 6.72. So the conversion of 20 degrees Fahrenheit to Celsius would be negative 6.72 degrees Celsius. That's converted to Celsius, am I right? Okay, please ignore it.
What is it?
Okay, class. And now, since we have Fahrenheit, we can also convert it to Kelvin. So for Kelvin, we put K equals Celsius degrees plus 273. Right? And then it'd be K equals, and then we get the temperature of the Celsius from up here that we got, which was negative, or it'd be 6.72. 6.72 plus 273. Y'all go ahead and do that on your calculator and get me an answer. And to help y'all do it, go ahead and scroll through this a little bit faster. Our answer would be 266.28 K, which would be Kelvin. 28 K. And that's how you convert Fahrenheit to Kelvin and Celsius. Now we have two more to go over. Now, if we were to have 132 degrees Celsius, so we go ahead and write 132 degrees Celsius. Now, when we have Celsius, we can only convert it to Fahrenheit and Kelvin. So we want to go ahead and write an F and a K so we know what we're converting to, and go ahead and put it in parentheses so we don't get lost. Is everyone with me? Okay. Now, to first convert it to Fahrenheit, it'd be F equals 1.8 and then degrees Celsius plus 32. That'd be the first thing part of the formula. And then it'd be F equals 1.8 degrees. And then we go ahead and get the Celsius degrees, which was 132. So we'll put 1.8 degrees and then 132 in parentheses and then plus 32, right? And then we go ahead and put F equals, and we want to multiply 1.8 times 132, and to help it short, our answer would be 237.6, and we can't forget about 32, so we still have to add 237.6 plus 32, and that's going to give us our conversion to Fahrenheit. To help you out, it's going to be F equals 269.6 degrees Fahrenheit would be our answer. So 269.6 degrees Fahrenheit. So that'd be how we convert Celsius to Fahrenheit. Now we can also convert Celsius to Kelvin. And for Kelvin, it's going to be the same thing as this one. So if you remember, it'd be K equals Celsius degrees plus 273, and then K equals, and we want to get our Celsius number from up here, which would be 132 plus 273, and we go ahead and add 132 and 273, and it's going to give us 405K. So to convert it to Kelvin, it'd be 405 Kelvin. Now we also have another type of conversion. We also have Kelvin. And Kelvin, we can only convert it to Fahrenheit, not to Celsius, because there is no direct conversion. So, for Kelvin, say we have 800 degrees. Is everyone with me? Now for Kelvin, it'd be C K minus 273, and then it'd be C equals, we'll go ahead and get our Kelvin, which would be 800K, and we'll put 800 minus 273, and we'll go ahead and subtract that, and to help y'all get a fast answer, our answer is going to be 527 degrees Celsius. So that's Celsius degrees converting in Kelvin. We can also convert it to Fahrenheit. Now for Fahrenheit, it's going to be quite exactly the same thing as this one. So we go ahead and be F equals 1.8 degrees Celsius plus 32. And then again, F equals 1.8 degrees. And we want to go ahead and grab our Celsius from up here, which was 527, and we'll put 527 in parentheses plus 32. Now, we're going to want to multiply 1.8 times 527, so it would be F equals, you multiply 1.8 times 527, and it's going to give you 948.6. And then we can't forget about the 32 again, so plus 32. And then you add that, and your final answer would be 980.6. And that is how you convert temperature. That's how you do temperature conversions. Okay, class. Yeah, the second lesson of the day, what we're learning, as I said, chemical reactions. In chemical reactions, you have two sides. You have the left side and the right side. On the left side, you have the reactants. The reactants yield the right side, which is the products, right? That you begin with and which react with each other are going to produce a new substance. The substance can be a cation, which is positive, and an anion, which is negative. An ion is a single element with a charge. It can be negative or positive. We also have compounds. Compounds are two or more elements bonded together without a charge. We also have diatoms. Diatoms are single elements that when alone, they will always act like a gas. Our diatoms, we have hydrogen, oxygen, bromine, chlorine, fluorine, chloride, no, it's chlorine, fluoride, nitrogen, something else. Types of chemical reactions. We have synthesis, which are the type of chemical reactions where a compound is broken down into individual cations or anions, which again are negative and positive. So for an example, we have H2O. Marker. If we have H2O, that's our compound. It'd be decomposition, so we want to break it down. So it'd be H with a positive charge and the 2. The 2 comes from right here, next to the H, so you put it on the bottom. And then we put plus O, and O would have a negative 2 charge. And again, we put the 2 on the bottom. The hint for decomposition is we'll always have a single compound on the reactant side, which is the left side of the reaction. So as you can see, one single compound on the left side of the reaction. The opposite of decomposition is a synthesis reaction. So for a synthesis reaction would be H3PO4. And then we'd want to break it down. So it'd be plus P plus O2. And then we get the charges for these and for these, and it would then transform into H2 with a positive charge plus PO negative 3 as a charge with a 4 next to it. Then we go ahead and get all the atoms from the so it'd be 8 atoms, and then it'd be 8 atoms, and then 2 atoms, and then for the other one, it'd be 8 atoms, and then 7 atoms, and we go ahead and cross it out, and that is a chemical reaction. Now another type of chemical reaction we have, that was decomposition. We also have single replacement. Single replacement, we go ahead and put SR for short, single replacement. Single replacement are the type of reactions where a single compound reacts with either a cation, positive, or anion, negative. Now, an important hint here is positives replace positives. So we write positives replace positives and negatives replace negatives. Replace negatives. Okay, so a hint for a single replacement chemical reaction would be they will always have a single compound plus a charge, positive or negative, on the reactant side, which is the left side. So if we have HCl, which is hydrogen chloride, plus Na, which for those of you who don't know is sodium, it would become, after breaking it down, it would become H with a positive charge and a number 2 on the side, plus NaCl, which would be sodium chloride. And then we also have sodium chloride plus oxygen, which has -2 charge. Go ahead and put Na for sodium with a positive charge and O for oxygen with a negative charge. I'm going to go ahead and crisscross them, so the positive will become a negative and the negative will become a positive. So it'd be negative, sodium will become -2 and oxygen will become a +1. And then it would change into chlorine with a negative charge and a 2 on the bottom, plus sodium, which would be Na, and then another 2 oxygen would be sodium oxygen. And this is single replacement. And we also have double replacement, which is our reactions where 2 compounds react with each other to produce 2 new compounds. So, an example of double replacement, DR for short, is hydrogen chloride again, which is HCl, plus CaO, which would be calcium and oxygen. We go ahead and we want to switch the HCl and the Ca. So it'd be, on the HCl would be Cl on the bottom. The Ca would have a +2 charge and chlorine would have a negative charge. And the CaO would become H with a positive charge for hydrogen and O with a -2 charge for oxygen. And again, like in a single replacement, we're going to crisscross. So the +2 would go on chlorine and the negative would go on calcium. And the positive for hydrogen would go on oxygen and the -2 for oxygen would go on hydrogen. And once we get that, it gives us, it would transform into CaCl2 plus H2O. And that would be a chemical reaction for double replacement. Another example we have would be H3O4 plus Fe, which is iron, and Cl3. Now, when we break it down, it'd be Fe, and then H by itself and Cl by itself. It would then transform, after doing crisscross and all that, it would transform into Fe4 plus HCl Cl, which is hydrogen chloride. Another type of chemical reaction we have would be combustion. So we'll go ahead and put combustion. Now combustion is a whole lot easier than decomposition, single replacement, and double replacement. For decomposition, you never bring down the subscript for individual elements. You can only bring down the subscript when it involves a family. Now, combustion is a carbon-based compound plus oxygen, or water plus carbon dioxide. An example of combustion would be C. It'd be C plus which would then convert into H2O plus CO2. In short, H2O and carbon dioxide will always be on the same side. Chemical reactions.